Good evening, Titans. And tonight we're going to be talking about subtracting real numbers. Mr. Spilker spoke about adding real numbers. Now we're going to be talking about subtracting real numbers. We're going to use some form of beans to model subtraction. We'll define subtraction in terms of addition. And we'll also subtract numbers with like and unlike signs. First of all, for this bean activity, we'll do this in class, but just to give you an idea of what's going to happen here, a plus sign is going to represent positives, and a negative is going to represent negatives, obviously. So in this first problem, we're going to set it up just the way it is. So we have 3 minus 7. And what we do when we're doing subtraction is we're going to add the opposite. So we're going to keep these 3 beans right here the same. We're going to change subtraction to addition. And now we have to change each of these to their opposite sign. So each of these are going to become a negative. And now we just use our rules for addition. Well, the thing with the beans though, we're going to look for neutral pairs. So I'm going to connect opposites attract. So this negative connects to that and goes to 0. This positive goes to that one and makes that go to 0. This positive attracts to that one and goes to 0. So then I'm left with just those 4 negatives. So my answer to this would be a negative 4. Let's go ahead and look at one more example here. We won't do all 3, but we'll do one more. And so we're going to take a look at this third one here. So we're going to start out and have 4 negatives minus 3 negatives. Now again, we're going to keep those the same. We're going to change subtraction to addition, and then we're going to change all these, make these into positives. And now we're adding. So again, we look to see if there are neutral pairs. So this negative attracts and goes away. This negative attracts and goes away. This negative attracts and goes away. So I'm left with just one negative. So my answer to this problem would be a negative 1. We're going to do more of these in class tomorrow. So what it comes down to for the definition of subtraction is that for all numbers a and b, if we have a minus b, that means the exact same thing as a plus the opposite of b. And so we change subtraction to addition by adding the opposite. So this is adding the opposite of what we're subtracting. Now an easy way to try to remember this, and what we like to say is keep, change, change. And I'll show you how that works in this next example. So if we take a look here, we have negative 51 minus 17. Well, we're going to keep the negative 51. We're going to change the minus sign to a plus sign. We're going to change the 17 to a negative 17. Now we use the rules of addition. So in this case we have same signs, so same signs add and keep. Different signs subtract. Take the sign of the larger number, your sum will be exact. Well, in this case it's same sign, so we're adding and keeping, and we get a negative 68. In the second example, again we're going to keep the negative 22. We're going to change the minus to a plus, and we're going to change the negative 3 to a positive 3. Now, as the song goes, different signs we're going to subtract. So we're going to take 22 minus 3, we get 19, and then we take the sign of the larger number, so our sum will be exact. And that's how we get a negative 19. So here we're just going to look at a couple examples with decimals and one with fractions. So again, I'm going to keep, I'm going to change, and then I'm going to change. And now I use my rules of addition. Well, the signs are different, so I have to subtract. So I take 5.6 minus 1.45. Notice how I line up the decimals, add a 0 there, and now subtract. So I have to borrow, make the 6 a 5, a 0 a 10, 10 minus 5 is 5, 5 minus 4 is 1, 5 minus 1 is 4, and then I look back, and since the larger number is negative, my answer is a negative 4.15. I'm going to erase this before I do the fraction problem. So now if we take a look at the fraction problem, again we're going to keep, and we're going to change the minus to a plus, and we're going to change the 4 1/5 to a negative 4 1/5. And now we use the rules for addition. So we have the same sign. So that means we're going to add and keep. So we have to have common denominators. So our denominators are 3 and 5. So our common denominator is going to be 15. So we're going to have 1. And we're going to change 2/3. Well, 3 times 5 is 15. So 2 times 5 is 10. And then we have to change the 4 and 1/5. And we're going to make that a denominator of 15. Since this has to be multiplied by 3. 1 times 3 is 3. And now we're ready to add. 10 plus 3 is 13 fifteenths. And 1 plus 4 is 5. Now, same signs, add and keep. So my answer is a negative 5 13 fifteenths. Now, I'm going to go ahead and erase this before I do the last example. So now, we're asked to evaluate this expression. And sometimes the easiest thing to do is to go through and just make it plus a negative. So I'm going to keep, change, then we have this. And now, x is equal to 5, but they want us to do the opposite of x, so that would be a negative 5. Plus, y is a negative 3, but we want the opposite of y, so that would be a positive 3, plus z, and z is a negative 10. And now we just add. Negative 5 plus 3 is negative 2, plus negative 10 be a negative 12. And that's evaluating using integers and adding and subtracting. Alright, one last thing is just measuring the distance on a number line. To find the distance between points A and B, we subtract the values and then find the absolute value of the difference. So for example, if we have negative 4 and 2, to find out how far apart negative 4 and 2 are, well, we can take 2 minus a negative 4. Again, we keep, change. That becomes the absolute value of 6, which is 6. Or we have the absolute value of a negative 4 minus 2, keep, change. And that would give me a negative 6, and the absolute value of that is also 6. Now, common sense might even be more helpful here. If we place a negative 4 on the number line and we place 2 on the number line, well, how far apart are they? Well, since we have to pass through 0, it makes sense that we have 4 and 2 there. And so we have a total of 6 spaces from each other. And so we take a look at these last problems here. And so if we just follow what they say, we subtract them and do the absolute value. So we're going to take the absolute value of a negative 5 minus 3. And so we keep, change. Negative 5 plus negative 3 is a negative 8. The absolute value of a negative 8 is 8 units. So these numbers are 8 units apart. Here we have a negative 2 minus a negative 13. And if we do this one, again we keep the negative 2, change. Signs are different, so we subtract. We get 11, and the absolute value of 11 is 11. Now notice again, both those numbers are on the same side of 0. And so to get from a negative 13 to a negative 2 on a number line, it would just be 11 spaces. All right, and that kind of sums it up. There's going to be I would like you to try these, and we'll reveal the answers tomorrow in class, but use the rules of keep, change, and then your rules for addition, and just see how you do with these. All right, have a great rest of the evening, and go Titans.
Made with Doodlecast Pro.